Hello, I'm Jared Skeens, and welcome to the Zoom room. Today, we want to start the first unit in the Pure Maths 1 Cambridge curriculum, and we're going to start in the topic of quadratics. So Pure Maths 1, quadratics is going to be our first unit, part 1, and today we're going to look at factoring. Actually, factoring isn't particularly a question type itself, but in the quadratics unit, you will have to factor frequently. And so you can view this as prerequisite knowledge that you should already have, and it's going to be very important that you are efficient at factoring. Otherwise, you're going to struggle with the quadratics unit. So this is the first topic that we want to cover. Make sure you're up to speed on your factoring before we get into some of the other topics within the quadratics unit. So here I have a basic general layout of the different types of factoring that you might run across. And we're going to focus in on specifically the types that you'll need for the Cambridge curriculum. But I want to introduce it to you generally first, and then we'll look at examples of each one. So in first thing that we want to look at is what is factoring? Well, factoring in algebra is basically division. It's a form of division, and it's a division where it divides evenly. Evenly means it goes in exactly without any remainders. So, for example, if you take the number 12, you can divide 12 by 3, and you get 4. There's no remainders. It divides evenly. So we call those factors of 12. You can also divide 12 by anything except 0. And so if you divide 12 by 5, you see it does go in, but it doesn't go in evenly. There's a remainder that's left over. And so you get this decimal answer. And so we would not consider 5 to be a factor of 12, even though it does divide into 12. So factors are, first of all, it's a division, which is important to know what operation you're doing. And it is a division that goes in evenly or without remainders. So when we look at the number 12, we should very easily be able to come up with a list of factors of 12. And all you have to do is just like start with 1. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. You can continue around the list. 12 divided by 4 is 3. 12 divided by 6 is 2. 12 divided by 12 is 1. So these are a list of the factors of 12. And we often put them in the pairs. So 1 and 12, 2 and 6, 3 and 4. And you can always double check, multiply them back together because multiplication is the opposite of division. Multiply them back together to get the original number. So this is kind of what you want to have in your mind when you're dealing with factoring. It's a division, and so this gives you a brief idea with basic number. We're going to apply this and see how it works in algebra. So basically in algebra, you're going to have 4 different general types of factoring. And it's we're going to divide it into 2 questions that you should ask yourself. And we see these types: monomial. Mono means 1. Monomial means 1 term. Binomial means 2 terms. Trinomial is 3 terms. And then when you have 4 terms or more, we call it factoring by grouping. Okay, so with these over here, it has to do with the number of terms in the expression. So there's 2 terms, 1, 2, 3 terms, or 1, 2, 3, 4 or more terms in the expression. With monomial, it's not about the number of terms in the expression, it's that you're bringing out one term to the front. Okay, so you're dividing out one term, whether these have to do with the number of terms in the expression. So we're going to want to separate this into two questions. The very first question, a lot of people sometimes overlook this. If you overlook monomial factoring, you can make it more complicated than what it needs to be. So please, the first thing you should always look for when you're considering factoring is monomial factoring, which means, is there one term that's common to all the terms of the expression? Doesn't matter how many terms are in the expression. Is there something common to each of those terms? So as you look here, you see there's an A common to both. So that means the A can be divided out. And when you divide out the A, the X is left and the Y is left. And so this is an example of monomial factoring in a general expression here. So that's going to be the first thing that we look at. And it should always be the first question you ask yourself when you consider factoring before you entertain any of these other options. Once you have done that, and maybe there's nothing common to all the terms, maybe there is, but once you have at least addressed that question, then you move to the second question, which is how many terms are in the expression. So all of this is based on the number of terms. So you can have 2 terms, 3 terms, or 4 or more. Now, in binomial, again, bi means 2, in this case, the number of terms. When there are 2 terms, there are actually several different factorings that can be done with 2 terms. But Cambridge, at least in the Pure Maths 1, only focuses on one type. So that's what we're going to focus on. There is a sum of cubes. There's a difference of cubes, but Cambridge does not cover those 2. There is also a sum of squares, but you don't get to that until Pure Maths 3 in the complex number chapter, because a sum of squares involves conjugate pair of complex numbers. So the difference of squares is the only 2-term factoring that Cambridge really focuses on in its curriculum. So we'll take a look at that. And then when you move up to 3 terms, generally trinomial factoring, sometimes might call it quadratic factoring because it has a quadratic in it. This is going to be a very common one that you really need to get a grip on. So we're going to spend some time on this. This is going to be our main focus right here. And then not so much in Pure Maths 1, but since we're reviewing, it is found in some of the IGCSE material. And this is 4 terms or more, generally 4 terms, and we factor it by grouping. So we're going to look at these monomial, binomial, and factoring by grouping relatively quickly just to demonstrate them. But we're going to really spend the most of our focus on the trinomial factoring, which is going to be the most of what you're going to run into in our Pure 1 quadratics content. There will also be binomial because it does have quadratic as well, just not as common as the trinomial factoring. Okay, so I'm going to set this up and we'll look at these, some of these briefly and more in depth in this one here to make sure that you have a good understanding of factoring before we start getting into the material, so that hopefully you don't struggle when you run across those. They're not a separate question type by themselves, but you will run into them in the problem solving, and you need to be able to deal with them as you run into them. Okay, our first type of factoring that we want to look at is the monomial factoring. And again, I've kept it simple so that I can point out to you what exactly it is that you're looking for. And so I've only selected 2-term expressions, but really it can come from any of a number of terms. The number of terms does not matter, but what matters is you're asking this as the first question. Is there anything that is common to however many terms that the expression happens to have? So really, you're looking for two things. The first thing that you're looking for is a number that is shared, or a factor specifically that is shared by each term of the expression. So when we look at this first one, I'm thinking, can I divide a number evenly into each number or each coefficient of the terms of the expression? So when we look at this, we see that 3 is divisible by 3, and 12 is also divisible by 3. So we're going to want to factor out a 3. So the 3 becomes the monomial, the one term that we're dividing out. So we take out 3. Remember, it's a division. So when you divide 3 by 3, the 3's cancel, and you're left with the x. And when we divide 12 by 3, it becomes 4. So we retain the sign here. It still stays plus. And then 12 divided by 3 is 4. So instead of using the division of the 3 as in a fraction like a denominator, we bring it to the front and treat it like a factor. So it's just a different notation for division instead of what you normally think of as a fraction bar type division. We're factoring it out to the front instead of putting it underneath like that. So we show that 3 is one factor and that the x plus 4 is another factor. Later in the pure math 3, when you get to polynomials, you'll learn how to do long division with algebra, just like you do long division with basic math. But you don't really need long division and basic math to do factors. Those are things you can do in your head just by looking at the numbers. And so we don't need that long division process. So when you divide it, this is what's left over. Now, in addition to the factoring, just briefly also want to touch on the solving part. So if you continue this into a solving situation, meaning instead of having an expression, you actually have an equation, which means now we can find the value of x instead of just expressing it. When you factor something, or if you use factoring in a solving situation, which you wouldn't necessarily have to, you could solve 3x plus 12 equals 0. In fact, I'll just put it over here just so that you see that it comes out to be the same thing. Normally, in solving, you would probably just do it this way, where you would subtract 12 from both sides, and this cancels. You get 3x equals a negative 12, divide by 3, and your x equals a negative 4. So this would be your normal problem-solving technique. But if you use factoring, which is just as legitimate, you end up with this. And so when you factor, you get what's called the zero product rule. So we get a factor or a product that equals 0. So a 0 product. And the only way that you can get a 0 by multiplying is if one of your factors is 0. So one factor is 3. Well, obviously that can't equal 0. And you see over here, your factor of 3 got divided to the other side. If you divide the 3 to the other side, it disappears into the 0. So the factor of 3 cannot be 0. Then that means your x plus 4 has to be 0. And then when you solve for x this way, you still get x equals a negative 4. Same answer, but just a different method of doing it. So solving by factoring is very common. That's what you're going to use this factoring or these methods of factoring for, is to help you solve problems that aren't quite as simple as this method right here. When it gets more complicated, you can't follow this all the time. So we're going to follow this kind of a pattern. But that zero product rule is important. The only way you can multiply and get 0 is if the 3 is 0 or if the x plus 4 is 0. Obviously, the 3 is not 0. It means the x plus 4 has to be 0, which means in order to get 0 here, x has to be -4. That is what gives you the solution to that particular problem. So the factoring part is extremely important skill that you should have already developed. So I hope this is a review for you, okay? So let me get rid of this one over here because we're focusing on factoring and move to the next one. Now notice I said there's two things you're looking for. And this one, the first thing that we're looking for is a number that divides out of each coefficient evenly. The second thing you're looking for is a variable that you subtract out. Now, what does that mean? You said factoring was division. Now, why are you saying subtract? Well, because now we're dealing with exponents. And remember your rule for exponents when it comes to division is subtraction. So maybe you're thinking about that. What do I mean? If you have a to the m divided by a to the n, you get a to the m minus n. In other words, when you divide out a letter or a like base, you subtract the exponents. That's what I mean. You're looking for a letter that you can subtract out from the exponents. So if you have x cubed over x, then that means you have x to the 3 minus 1, which gives you x squared. So if you want to look at it this way, you have 3 x's, that's x cubed. You divide by 1x, well, that cancels one of them out, and you're left with 2 factors of x, or x squared. So however you want to look at it, the bottom line is with exponents, it's subtraction. Okay, so that's what I mean by you're looking for a variable that you can subtract out of the exponents. Okay, and again, it has to, fit what they have. This one has 3, this one has 1, so you can only subtract out 1. You can't subtract out 3. This one doesn't have 3 to give. Okay, so that's what we're looking for, is a variable that can subtract out. So in this case, we see there's an m common to both terms. So we divide out the m. Since it's a variable, it means we're subtracting it from the exponent. Okay, so this is an understood power of 1. So 3 minus 1 leaves us 2 factors of m left over. And then we keep our sign, the plus, and then this has an understood 1, and this is an understood 1. So 1 minus 1 is 0. Well, what's anything to the 0 power? Remember, we're dealing with exponents. You don't put 0 here. It's now like this. M to the 1 over m to the 1 is m to the 1 minus 1, which is m to the 0. And if you remember your exponent for 0 exponent, you get 1. So this m divided by m, anything divided by itself is 1. Okay, so this follows your exponent rules. So just quickly, if you remember what is a term has the sign, the coefficient, the variable, and the exponent. Okay, so these two are your basic math. These two are your algebraic part. So in this one, you're subtracting out a basic math that is a positive 3. In this one, you're subtracting out or dividing out, you're dividing out the basic math. Here, you're dividing out the algebraic part, and that is an m with an exponent of 1. Now, over here, we're going to see both together. You need to take out in your one term everything that's possible to divide out of your expression, okay? So make sure that you take out everything that you can. So when we look at this one, again, we're looking for two things, a number and a variable. So I see that we can take out a 4. 4 divides into 4, 4 divides into 16. Notice 2 divides in as well, but 2 isn't all that I can take out. So don't settle for 2 because it will complicate it later. Take out everything you possibly can. So we want to divide 4 is the biggest number that we'll divide out. And we're also looking for a variable. So this one had a number but not a variable. This one had a variable but not a number. This one has both. There's an x that can come out. I can only take 1 because this one only has 1 to give. So when I divide it out, you're like, oh, how do I divide that? Well, again, just remember it's division. So if you divide by 4x, 4 divided by 4 cancels. So we're left with 1. And with exponents, you subtract. 2 minus 1 is 1. That means we're left with just x. 4x times x is 4x squared. Keep the sign minus, and 4 goes into 16 4 times, and we subtract out the x, and there's no more x's left. So we end up with 4x and x minus 4. Again, if we move it forward into the solutions, this one here would be m squared plus 1 equals 0. Our product rule for 0 means that either m has to equal 0 or m squared plus 1 equals 0. When you solve this one, you get m squared equals a negative 1. And when you try to square root both sides, you're going to stop right here because you can try it on your calculator. It will give you syntax error. You can't take the square root of a negative. Actually, this gets into imaginary numbers or complex numbers, which you'll get into Pure Math 3. So for now, in Pure Math 1, we only deal with real numbers. And so we'll say this cannot equal. We cannot get the square root of a negative 1. So this one will stop. It's called irreducible, or this one actually right here is called an irreducible factor. Does not give you a real answer solution. And so your answer would be just m equals 0. Okay. If we come over here to this one, we then take our factors. 4x times x minus 4 equals 0. So that means 4x can equal 0. Divide by 4, x can equal 0. Or x minus 4 can equal 0, plus 4 to both sides. X can equal 4. So you end up with 2 possible solutions with that one. So notice your exponent will give you the number of solutions. Your exponent was 1, you got 1 solution. Your exponent was 2, you got 2 solutions. Here your exponent was 3. Technically, you do get 3 solutions, but only one of them is real. The other 2 are conjugate pairs of imaginary numbers. Like I said, you'll get to that Pure Math 3 and complex numbers. So you don't have to worry about that now. When you get to the square root of a negative, you just say can't equal and don't worry about it. So you'll only get one answer here. So this is monomial factoring. Very important first question. I see a lot of students who jump into other types of factoring without first considering monomial factoring. They get confused because it leads you into complications you don't need to be. First, check for this. Okay, so let me set up for binomial and we'll continue in our look at factoring. Okay, here we go with binomial. Now we're moving into the second question. After you consider monomial factoring, that is, if something's common to both terms, and you first consider that, And that doesn't work. Like if you look here, there's no number or variable common to both. There's no number or variable common to both. Once you've considered monomial factoring, then you go to question number 2. How many terms is in your expression? And in all 3 of these cases, there are 2 terms, hence the binomial 2 terms. So this is a 2-term type of factoring. And like I said before, there are actually several factorings that can be done from 2 terms, but Cambridge does not cover sums of cubes, difference of cubes, so you don't need those. There's only one type that you need for Cambridge that involves 2 terms, and that is the difference of squares. So what a difference of squares is, first of all, it is a difference. You'll see a subtraction sign. If you see an addition sign, you will not be able to factor it. You'll have to figure out something else to do, but you won't be able to factor it if there is a plus sign, okay? So it is a difference of squares. It means both sides of that subtraction sign should be a perfect square. And if they are, then this is your pattern. A plus b times a minus b, those become the factors of your binomial. So when we look at this one, we see nothing is common to both terms, and we have 2 terms. So this is a binomial, and the only type of binomial that you have to worry about is the difference of squares. So you should ask yourself, can I write these as squares? So this one is x squared, and yes, you can write 25 as 5 squared. So now you see it's a difference of squares. Now all you have to do is follow the pattern. You don't need the squares, you just need the a and b. So you have a, which is our x term, plus b, which is the 5, and a minus b. Okay, so x plus 5, x minus 5, that's our difference of squares. And if you put this into a solving situation, then x plus 5 equals 0, or x minus 5 equals 0, because it's our 0 product property. And so you either end up with a negative 5, or you end up with a positive 5. Now that should make sense, because if we solve this a different way, like directly, like what we did before, if we add 25 to both sides, we get x squared equals 25. And when we square root both sides, remember with square roots, you have to introduce the plus or minus. So you get x equals plus or minus 5, which is the same thing. So this is one method. Factoring is another method, but you never know when you're going to run into the factoring. It's not always in a solving situation. Sometimes it's in a simplifying situation where you're simplifying fractions so that you can cancel something top and bottom. So factoring is a very important tool to make sure you can identify those factoring situations to make your algebraic life a lot easier for you, okay? So here's one way of doing that. We're gonna get rid of this one over here because we're focusing on the factoring. Now we look at this one, say, oh, this one's a little bit more difficult looking. Well, remember, there's nothing common to both terms. Always the first question you should ask. The number doesn't divide into 4 or 9 evenly, and there's not a variable that you can subtract out. So we go to the second question. The number of terms is 2. And the clue is there's a minus in between it. So that's a difference. Can we make it a difference of squares? Well, let's see. Can you write 4 as a square? Yeah, 2 squared. Our x is already squared. Minus 9 is a 3 squared, and the y is already squared. So now we have a difference of squares. It's just that our a is now a coefficient and a variable, and our b is also a coefficient and a variable. Over here, it was either variable or a number. Now it's both together. So we have 2x plus 3y, and we have 2x minus 3y. Okay? So that's how you do your difference of squares with that one. So I'm going to move this out of the way so that we can get to this one over here. We won't do the solving. I think you get the general idea of the solving. Now we get to this, and you look at this and say, okay, a difference of squares, but 8 is not a square. How do I write 8 as a square? That's what you got to remember. You go back to the first question. Is there something common to both? There's a 2 common to both. So make sure you ask that monomial question first. Is there something common to both terms? Otherwise, it might make it complicated. You might get stuck. So say, is there something divides into these? Yeah, I can see that 2 goes into it. 4 goes into this, but 4 does not go into this. 8 goes into this, but 8 does not go into that evenly. So we'll just take 2 out. We take 2 out. That leaves us with 81 minus 4t squared. And you go, there, I'm done. Not yet. You did monomial factoring, but now that you've done the monomial, you still need to ask the second question. Can this break down further? In other words, you can have more than one factoring type connected together. So we did the monomial. Now we want to consider the binomial, or the difference of squares. So 8 can be written as 9 squared. 4 can be written as 2 squared. The t is already a square. And so we see we have a difference of squares. So now we get 2 and 9 plus 2t and 9 minus 2t. Okay, so this 2, don't forget to keep it, comes out front. This one, once you have it written as squares, then your a plus b and your a minus b. Then if you wanted to solve, you would get into this. Obviously, 2 cannot equal 0. When you solve this one, you end up with 2t equaling a negative 9, t equals a negative 9 halves. And on this one, you would end up with t equaling a positive 9 halves. So you get your solutions, 2 solutions. This one does not count as a solution because it doesn't have a variable in it and is an untrue statement, so it gets thrown out. And these 2 would be your solutions. So factoring is very important that you learn these factoring types. At this point, when you get to the A level of Cambridge, factoring is prerequisite. You're expected to already have a good handle on it. And I would say by the time you start quadratics, you should be a master of factoring. If you don't, you're going to struggle. Okay, so this is binomial, and I'm going to go to grouping, the 4 one, before I get to the trinomial. The trinomial is the one that we really want to focus on. So we'll set up for grouping first. Okay, with factoring by grouping, we're only going to look at 2 examples. I don't want to spend a whole lot of time. Generally, you're not going to run into this in Pure Maths 1. The reason why I'm covering it for review is because you will run into it in IGCSE. The IGCSE does include this in their testing for factoring. So I'll just briefly explain it in case you're looking at this and you're maybe still in the IGCSE curriculum. So again, you have the first question, monomial factoring. Is there something common to all the terms? It doesn't matter how many terms there are for that first question. So if you look here, you're like, oh, this is divisible by 2, this is divisible by 2, this is divisible by 2, but this one is not. Or this one has an A and this one has an A, but those don't. Or these have a P, but this does not. So you can't find a number or a variable that is shared by all the terms. So monomial factoring we can't do on this particular one. So after we ask that question, we then go to question number 2. How many terms are we dealing with? If you're dealing with 4 or more, and IGCSE usually just keeps it to 4. So if there's 4 terms, what you're going to want to do is you're going to want to group them. And really, the easiest way to do that is to just split it in half, 2 and 2. Especially if you have 4 terms, makes it even, 2 on one side, 2 on the other side. And there may be an example where you might have to rearrange the terms, but most of the time you should be able to just split it in half. Have the left half, the right half. If it doesn't work, then you might have to rearrange and choose 2 that have something in common on one side and the other 2 that have something in common on the other side. But most of the time, you can just split it in half. So when you look at these 2 and you see that they both have a 2 in common. So you're going to factor the 2 out. Remember, you're dividing it out, so that leaves you with a plus 2. Then you look at this side over here, and they have a p in common. And you're going to take the positive sign here. So a positive p is what's common to these 2. And when you divide that out, you get an a plus 2. Now, notice again, just to reiterate, most of the time when you have 4 terms, you can just cut it in half, deal with the left 2, deal with the right 2. Occasionally, that might not work. So you might need to rearrange. For example, 2a could go with AP because they both have an A in it. And 4 could go with 2p because they both have a 2 in it. So if you need to rearrange your group of 4 so that you can factor this 2 and those 2, you can do that, just in case you run into one of those situations that you need to rearrange it. Usually you don't have to. So in this case, we just cut it in half. This one shared a 2. This group shared the p. Now, here's the important thing. The important thing is, after you do this first step, what you have in parentheses needs to be the same. If it's not the same, you've done something wrong. Make sure that this parenthesis is the same as that. If it is, then that means you're doing it right and you can proceed to the second step. So factoring by grouping is actually 2 successive factorings, but you're doing it in groups. So we factored this group and this group. Now we're going to factor again. So instead of having 1, 2, 3, 4 terms, we now only have 2 terms. Remember, terms are separated by plus and minus, not by multiplication. So this starts off with 1, 2, 3, 4. This one now only has 2, and there is an a plus 2 common to both of these terms. So we factor out the a plus 2, and what that leaves us here is this 2 and the p. Okay, so here's our 4 terms. Now 2 terms, split it in half, take out what you can. Now these 2 are common, take it out, and then what you have left is the remaining factor. Okay, now this one we're not going to do solutions with because we have 2 different variables. This isn't really for solving. This is just the skill of how to factor it. Now we come over here, again, check the monomial factoring. Divide by 2, divide by 2, doesn't divide by 2. How about a letter? A, no A, X, X, no X's, Y's, no Y's, V. So there's nothing that's common to all these terms, but we should check anyway so that we establish a good habit. Now we go to the second question, how many terms we have? Oh, we have 4 terms. That means we need to factor by grouping. So again, we're just going to split it in half here, 2 terms and 2 terms, and see if there's something common to both. So on this side, we see that there's a 2 common and also an X. Make sure you look for everything. So 2x, and that leaves us with an a minus 2b, okay? Now when we look at these two, we see that there is a y common to both. There's a y here. And so if I take out the y, that's going to leave me with a negative a. Remember I said these two need to be the same? So if we take it out like this, it's going to be a negative a plus 2b, and these are not the same. So what it generally means is you need to put the negative on the y instead of on the a. So we're going to factor out the negative with the y. It's like dividing by a -1. So we're going to take out the negative so that when we divide this by a negative y, this becomes a positive a, and this then will become a minus 2b because we're dividing by a -1. 2 divided by -1 is -2. Take out the y, and we're left with the b. Now these two are the same, and now we can factor that out in our second step because those two are the same, common to both of these terms, and then what we have left is 2x and our minus y. So again, I won't go into the solving part because these aren't really set up for solving type situations. It's just set up for a factoring example. And this would be the type that you would see on the IGCSE level. But it's still a good thing to bring with you in the back of your mind, just in case you see it again in the future, okay? So this is factoring by grouping. So we've covered monomial, we've covered binomial, we've covered the factoring by grouping. Now we'll look at the main event, and that is the trinomial factoring. Okay, now we're ready for trinomial factoring. This is the one that really takes a little bit more skill and the one that you really need to get down in order to be successful in the quadratics unit. So we have two different layers of difficulty here. We have the x squared plus bx plus c, where the a is an understood 1, and then we have the ax squared plus bx plus c, where the a could be any other number. And so when you have another number out here other than 1, it gets a little bit more complicated. And so we're going to start with the easier version first. Got two examples up here. And before we get into that, what will help you in understanding what's going on is if you understand how the quadratic is formed in the first place. Remember, I like to train your mind before I train your skill. I don't want to just show you what to do, because if all you're doing is following a procedure and you don't have understanding, you have a much greater risk of getting stuck and confused because you don't really understand the process. So I want to spend a little time getting your mind to really see what's going on here before we get into the factoring. So let's start at the bottom. There's actually 3 steps in here that are quite important. This one up here is your equation. So this is one level in your mind that you should have. This is an equation, happens to be a quadratic equation. This one here is the factored form. It's the same equation, but it's in factors. Then this level here, this is the solutions that can be called the roots. Count your answers, your solutions. There's several different names it goes by, but this is your root to the equation. So you really need to know all 3 of these, and you should be able to start with one and go to the other one. Now, generally, we start with the equation and we try to work down to the solution. And in our working down to the solution, we go through this factoring level. That's why we're learning how to factor, so that we can get from the equation to the solution. So this goes in this direction. We should be able to take our equation and factor it, and then from our factors, we should be able to find the solution. But math works both ways. We can also take our solutions and we can come up to our factors, and we can take our factors and we can multiply it back together into our equation. In fact, that's called expanding. Factoring is dividing, expanding is multiplication. It's just going the opposite direction. So what we're trying to do is we're trying to go from an equation, or in this case, an expression, to the factored form. And if it was an equation, we could go to the solution. But to understand that better, if we go backwards so that you can see how it's developed, I'll give you a better idea of what it is you're looking for. So if we call this our two roots, this root is, we just call it P, and this root, call it Q. So these are two solutions to our quadratic equation. And if we subtract P from both sides, well, we get a negative P over here, and P minus P becomes 0, right? If we subtract P from P, we get 0. We subtract P from X, we get X minus P equals 0. Same thing with Q. If we subtract Q from both sides, we get X minus Q. We subtract Q from Q, we get 0. Then we just put it together for our zero product rule. Zero product rule is says, well, if this equals 0 and that equals 0, then you multiply them both together, you still get 0, right? 0 times 0 is 0. So in your product rule, it says if a product equals 0, means either this factor is 0 or that factor is 0. So we're just putting them back together. We're going in the opposite direction. Now, this is where the important part is. So as you look at this, notice as we expand. Now, I'm not sure what expansion technique you learned. Maybe you learned the FOIL method or some other method. I like to call it the smiley face method, where you draw a smiley face. So this one times this one, that's our x squared. This one times this one, negative p times negative q is positive pq. And then the nose is a negative px, and the mouth is a negative qx. So we get kind of like a little smiley face there. So I call it the smiley face method. And so you get these four terms, and you notice that these two contain an x. So we want to combine those because they're like terms, and we take out the negative, and so we have p plus q. So the important things to see here is that from our solution, we can see that our two solutions multiplied together give us this C term. That's very important. Our two solutions come from factors of the C term. That is the third term in our quadratic expression. And the two solutions added together, now we'll have to pay attention to the sign, but our two solutions added together gives us the B term. Okay, so that's very important in how we understand how this factoring works. By working backwards, we see the relationship of the answers to our original quadratic. Now, having said that, there's really only the important thing that you want to look at on this level is that second sign, okay? And also the fact that these solutions come from this number here. So our solutions are going to come from the 12. So what we need to do is, because these are factors of that, we just factor 12. So I make a list. 1 and 12, 2 and 6, 3 and 4. I just make the whole list right here on the side so I can see them. Okay? However many the list is, some lists small, some lists longer, depends on the number. So we know it comes from here. Now this is positive. That means that we are going to add these two numbers together. If it's negative, it means we're going to subtract the two. So keep that in mind. That's an important, helpful thing for you. After you list your factors, look to see whether you're going to add or whether you're going to subtract. We're going to add them together to get the b term. Remember, we add, but we have to pay attention to the sign. So here we're going to add them to get a 7, okay? So when I look at 1 and 12, 2 and 6, 3 and 4, which pair adds together to give me a 7? Well, obviously it's the 3 and 4 add together to give me 7. So now all I need to do, remember all trinomials break down into 2 binomials. So I set up my brackets. All trinomials break down to 2 binomials. My x squared is x and x. That one's quite easy. That's why this is an easy one. And then I have a 3 and 4 that are adding together to give me a positive 7. So it's a positive 3 and a positive 4 that are adding together to give me a positive 7. If this happened to be a negative 7, then you would be adding a negative 3 and a negative 4. A negative 3 plus a negative 4 would give you negative 7. So this tells you that you're adding, and this one tells you whether your signs are both positive or both negative, okay? But your factors, your answers, come from the C term, and they have to add together to give you the B term, okay? So that one was quite easy, and I'll just get rid of those, so hopefully that doesn't confuse you. Now let's move over to this one. Well, again, we know that our solutions are going to come from the 28. So I'll just list. I always start with 1 and just work down. That way you can go in order. You're not, skipping any. So 1 divides into it, gives you 28. 2 divides into it, gives you 14. 3 doesn't go into it. 4 times 7, 5, 6, 7, 8. No, so we now have our complete list here. 1, 28, 2, and 14, 4, and 7. Now, because of this minus, it means we want to subtract to get 3. Okay, remember, you say, I thought you said we had to add. Well, remember, subtraction is the additive inverse. Okay, so you'll see how that comes out. But for our help, we're going to subtract to give us the 3. And again, we can see that comes from the 7 and the 4. 7 minus 4 is 3. So now when we set up our parentheses, we have our x and x from our x squared. Now to get our 4 and 7, we can put our 4 and 7 in here. And we need to subtract. Now, if we do 4 minus 7, we get a negative 3. So this is really where you have to think carefully about the signs. So we want a positive 7 minus 4. It's the same thing as 7 plus a negative 4. If you're saying we're adding them together to get that number, remember, subtraction is the same thing as the additive inverse. So you can make a subtraction and addition problem if you're thinking about this adding together over here. Okay, so but just follow it as subtracting. 7 minus 4 is the 3. That means 7 needs to be the positive and 4 needs to be the negative. 7 minus 4 to get your positive 3. If this were negative here, a negative 3, then you would have your 4 be positive and you would be subtracting 7. 4 minus 7 is negative 3. So you can do it like that. Okay, so these ones with the 1 as a coefficient, these are the easier ones because you don't have to worry about the front. It's just x and x. So now I'm going to set it up for where we have this number here, and it gets a little bit more challenging. So I'll show you a couple ways that you can do that. Okay, here we have a more complicated trinomial where we have a coefficient in the front. So this complicates things a little bit. I noticed that most students struggle on this type more than the others. And so it's really important that you establish for yourself a method. There are actually several methods for factoring trinomials. In the previous example, I just showed you one method. I'm going to show you a second method that you can use, and I'll leave it up to you as to which one you want. There are even other methods. I tend to not prefer them, but if you look them up online, you can find other methods that are out there. What is important is that you can find a method that you can consistently use to be successful in factoring. And that's what's most important for you. It doesn't really matter which method it is, as long as you can find one that works for you, that you can be consistently successful at. So I'm going to show you again what I do and an alternative way that you can also sort of simplify it. Kind of comes with a pro and con. So here we have this in the front. So notice that our x times x comes from the x squared. Just like our PQ comes from the C, our x times x comes from the front term. Well, now we have a number in the front. So that means we need to factor both of them. So if I factor the 12, I get 1 and 12, 2 and 6, 3 and 4. If I factor the 6, I get 1 and 6, 2 and 3. Now, generally, I will start at the lower end because at the top end, it gives you very big numbers really fast. 6 times 12. Notice when you multiply this one times this one over here, or this one times this one, you're taking a factor from the C term and you're multiplying it by a factor from this ax squared term. It's this nose and mouth part that is making this challenging because we now have a coefficient on the x. So we got this multiplication going on here. So we have something from here multiplying something from over here. And if you take 6 times 12, you get 72. Obviously, you don't see a 72 on there. So generally, I start with the lower numbers first. You're more likely to find your solution set faster instead of starting at the top. So what you want to do is you want to multiply these numbers together. So just multiply 2 times 3, that's the first one times the first one. 2 times 3 is 6, and 3 times 4 is 12. Now remember, we want to subtract to get 1. Obviously, it's not 6 and 12. So change it the other way. Instead of 2 times 3 and 3 times 4, do 2 times 4 and 3 times 3. Just switch it up. So 2 times 4 is 8, and 3 times 3 is 9. Can we, by subtracting, get a 1? Yes. So we want this pair and this pair, and I didn't even have to go through the other pairs, okay? But if you notice, 1 times 2, and 36. Obviously, you're not going to get a 1 by subtracting 2 and 36. If we switch it, we get 12 and 6. Again, 12 and 6 don't give you 1. Or 1 and 72, or 12 and 6 again, okay? So there's only going to be one pair that work. It's something that's important with factoring is there's only one right way to do it. Only one right way. There's not multiple, when I say way, I'm not talking about methods. I mean the answer. There's only one correct answer to it. So if you can't find the right pair, then you can't factor it. You have to use the quadratic formula or some other method, okay? So in other words, it can't factor if these numbers don't work. There's only one set of numbers that will work if it factors, okay? So once you find the set, remember, you can multiply it 2 times 3 and 3 times 4, or you can multiply the 2 times 4 and the 3 times 3. If you need to write the numbers on the side so that it's easier, remember you're subtracting to get a 1. So you go, oh yeah, 9 minus 8 is a 1. Okay, so when we do this, we know that these are the first ones, so a 2x and a 3x. Now our 8 was the 2 times the 4, and our 9 was the 3 times the 3. So our 2 needs multiplied. Remember, we're dealing with the nose and mouth of the smiley face. The 2 needs multiplied by the 4, and the 3 needs multiplied by the 3. And since we want 9 minus 8, that means this one needs to be the minus. Subtract the 8. This one, the positive. So when you get to the end, just double check to see if it works. 2x times 3x is 6x squared. 3 times a negative 4 is a negative 12. 3 times 3x is 9x, and 2x times a negative 4 is a negative 8x. 9x minus 8x is, yes, a positive 1x. So you have 2x plus 3 times 3x minus 4. If you put this into an equation and you have it equal 0, that means you have 2x plus 3 equals 0, 3x minus 4 equals 0. Here you subtract 3, 2x equals negative 3, divide by 2, divide by 2, x equals a negative 3/2. Notice when I'm doing my work, since we're just starting at the beginning of quadratics, it's a good time to remind you good math procedure when you show your work. Show your work step by step. Here's your method, what you're doing, here's the result. Here's the method, what you're doing, here is the result. If you do this and you make a mistake, it's easy to work your way back through and find your mistake. If you just go method or result to result to result and you don't show your method, it's more challenging to find a mistake if you make one in your process. So do good math. Don't be so fast to just rush to the answer. You want to lay a nice paper trail so that you can verify your work, double check your work. And if you find out that you look at the answer and you made a mistake, it's quite easy to find where your mistake is at. So show good work. Again, both sides, plus 4, plus 4. If you want to cancel out, that's fine. 4, divide by 3, again cancels out, x equals 4/3. So here's my method, here's the result. Here's my method, here's the result. Good math, good procedure, you'll get good answers, okay? So here's how to do it. Now, this is the way that we did it in the first example. We factored the back number to find the middle. Here we have to factor both ends. I'm going to show you one other way that's similar to this that you can do that might help if it's difficult for you to work with both sets of numbers. So I'll set up that for you really quick. Okay, here we are. Same problem, but I'm just going to show you another way that you can handle it if you want to. Now, some students struggle with handling two sets of numbers, the factors of 12 and the factors of 6, that you either, after you multiply them, have to add or subtract them to get the middle term. For some students, that's too much to ask their brain to handle, unless you want to write all those things down on the side, can help a little bit. Here's another thing that you can do, and it comes with the positive and the negative. What you can do is you can take this 6 and you can multiply it to the back. Notice when we do this multiplication, we're taking a factor from the front and we're multiplying it by a factor in the back. So let's just take our factor from the front and multiply it to the back at the very beginning. So if you do that, you now get x squared plus x. You're not multiplying it through it, you're only multiplying it to the back. And that gives you 72. Now, here's where the plus and minus of this method comes in. On the positive side, you now only have one number to factor. You don't have to worry about the second set of factors. On the minus side, your number is bigger, meaning you're going to have more factors in your list. So you're going to have to see, weigh that back and forth. Sometimes this number gets very large, and that the negative side of it might be too negative for you to use this method, but sometimes it's not really that large, and it saves you from, again, having to work with two sets. So you'll have to weigh that for yourself, but I have seen several students use this method and use it effectively, so that's why I want to share it with you, because the goal is that you can succeed, okay? So what you do on this one is we've moved the 6 to the front. Now remember, you multiplied by 6. Don't forget that. So our factors of 72, well, we start with 1. 1 times 72, 2 times 36, 3 times 24, 4 goes in once, 4 goes into 7. 1 time that leaves 32. 4 times 8 is 32. So you have 4 and 18. 4, 5, no, 6. Yeah, 6 goes into it. 1, 12. 6 times 12. 7, no, 8. 8 times 9 is 72. So here's our complete list. You don't have to go 9, 8, 12, 6. Once you get to see where the numbers start going back up again, you're done. So it takes a little bit longer to make the list, and the list itself is longer, but you only have one set. And remember, again, we are subtracting to get a 1, and it's quite obvious. It's really easy because we see 9 and the 8. So we go with x and x. We have our 8, we have our 9, and we need to do 9 minus 8 to get a positive 1. So this one needs to be positive, that one negative. We need to do a positive 9 minus 8 to get a positive 1. So make sure you have your signs correct before you move on. Now, if you remember, our answer was -3/2 and 4/3, not 8 and 9. So this is the place where I see the students who use this method sometimes forget that they multiplied the 6 to the back, meaning you also have to divide by 6. In other words, you have to undo that step. So you multiplied by 6. This is where you divide by 6. And all you have to do is divide the number, your factors, by the 6. So we multiplied by 6. Now we're dividing by 6. So what you end up with is x minus, and that reduces to 4/3. This reduces to 3/2. And if you're solving it, what do you know? You get x minus 4/3 equals 0. You add 4/3 to both sides, and you get this one here. And if you have x plus 3/2 equals 0, you subtract 3/2 to both sides, and you get this one here, okay? Now, you might say, well, I don't remember having fractions in the previous one. Well, if you're going from equation to solution, it doesn't really matter. Now, if you're going from solution back to the equation, you don't want it in this form. What you can do is, remember, each of these factors are equal to 0. So you can multiply, actually I shouldn't do it like that. Yeah. You can multiply your factor by 3. In other words, get rid of your fraction. So if you're wanting to see the factors without the fractions in it, just get rid of your fraction. We have to multiply by the common denominator, which is 3. You multiply by 3, and you get 3x minus 4 for this one. And if you multiply this one by 2, because that's the denominator, you get 2x plus 3. Those, you might remember, were the factors that we had when we did it with numbers on both sides. So this gives you 6x squared, negative 12, 9 minus 8 is the 1. So this is the factors that we had before. And then when we solved them, you got your 3x equals the 4, and you divided by 3 to get your 4/3. You had your 2x equals negative 3, divide by 2 to get the negative 3/2. So the factors show up in a little different form because we're dividing into it like this, but your solutions are the same. You can convert one to the other if you need to. For the most part, you're not going to need to. The goal that you're going to be using this for is to get from equation to solution. So whether it looks like this or looks like this, doesn't matter. You get the same answers either way. But you can convert them if you needed to, okay? So this is just a different way. Like I say, it has plus and minus. The good thing is you're only dealing with one set of numbers. That's really nice. Your mind can focus on just the one set. But the downside is this number can get big really fast, and it takes a little more time to make that list out. So it's up to you, but I hope that you can move forward into our quadratics unit. This is all prerequisite. You really need to be masters of factoring. The better you are at factoring, the faster you will move through quadratic type questions, because many times you get to a quadratic through some other part of the question, you arrive at a quadratic, and then you have to solve it. And the main and most, the fastest way of solving a quadratic is by factoring. That's going to be your first go-to option, so you really want to be good at it. So take time to practice this. Do whatever it takes to become efficient at factoring. That is going to be the key to your success. If you're good at factoring, then you can spend your time focusing on the other skills that we'll be developing in the quadratics, but they will frequently come back to this. And I just hate to see students struggling with new information when they still haven't gotten the old stuff that they should have gotten by now. Okay, so good luck, and I hope that you too can be successful in this quadratics units. So I'll see you later for part 2 of this series.